resolution of vector. Resolution of vector means splitting of a vector into x component and y component. We have drawn Cartesian coordinates x-axis and y-axis, then a vector, say the vector A. Vector A is making angle theta with x-axis. Now as we are going to split it into x component and y components, let's draw a line from the vector A to the x-axis and from the vector A to the y-axis. The line which is along with the x-axis from here to here, it is under the vector A, so write it A. It is on x-axis, so write it AX. Now this line is along the vector A and on the y-axis, so write it AY. We have a triangle, this one triangle. Let's redraw this. Okay, we are starting from point O. This is the triangle. We draw it here. On here, x-axis AX. On here, vector A. On here, it is along the y-axis AY. The line where angle is starting is known as the base. The line where angle is end is called hypotenuse, and the line in front of this is known as perpendicular. We have a geometrical shape that is a triangle, and to solve the triangle we use three formulas, that is cos theta, sin theta and tangent theta. These formulas respectively give us x component, y component and direction. We are going to find other than these three magnitude. Okay, let's start from the x component. Cos of theta. The formula of cos of theta is equal to base upon hypotenuse. Cos of theta is equal to base. The line base is AX divided by hypotenuse. The hypotenuse is vector A. A is dividing here. When I will shift it, it will multiply with the cos of theta and AX. Now on the equation one side I have AX, and on the equation's other side I have vector A cos of theta. This is called x component. So this is equation number 1. Now let's solve for the y component. We are going to use sine of theta. Sine of theta is equal to perpendicular upon hypotenuse. Let's put the values here. Sine of theta is equal to perpendicular. On perpendicular we have AY. Hypotenuse. On hypotenuse we have line vector A. A is dividing here. When I will shift it, it will be A multiplied by sine of theta is equal to AY. On the equation one side I have AY. On the equation other side I have A sine of theta. And this equation stands for y component. Now let's solve the direction. For direction we are going to choose tangent of theta, which is equal to perpendicular upon base. Tangent theta is equal to perpendicular. On perpendicular we have AY, so write AY. On base we have AX, write AX. Now we know very well any vector which don't have the power, it has the power +1. Okay, here the power is +1, and when I will shift on the other side of equation, it will be -1. Okay, we are just shifting tangent power +1 to the other side, so it will become -1 and already written AY upon AX. So this stands for direction. Direction of this vector, vector A, direction of vector A in terms of x and y components. One thing is remaining, that is magnitude. How we are going to know the magnitude? You are going to use the Pythagorean theorem. Okay, let's apply the Pythagorean theorem. Say this is your equation number 3. The Pythagorean theorem says that hypotenuse square is equal to base square plus perpendicular square. Hypotenuse. This line is hypotenuse, and what's on hypotenuse? That is vector A. So put the value vector A with square base. On base we have Ax. Write Ax, and there is the square. Perpendicular. What is on perpendicular? On perpendicular we have AY. So write AY. Now we have the equation on which there are square, square, square. What we are going to do to eliminate the square? Taking square root. Okay. We are going to apply an operation on this equation, and whenever we apply our operation, it applied on the both side of the equation. It's mean on the left side, also on the right side. Okay. Now this is square and this is square root. It will be cancelled. We will get the A. These squares cannot be cancelled because we have the plus sign in between them. So we are going to write it as it is. Okay. For what we were going to solve this? We were going to solve this for magnitude. So for magnitude, we always put modulus along the vector A. We get the equation, and now this equation stands for, say this was equation 3, say this is equation 4, and this equation stands for magnitude of vector for magnitude of vector in terms of x and y components. So to solve this topic, that the resolution of vector, you all need to apply the geometrical formulas, that is the cos theta, sin theta, tangent theta, and Pythagorean theorem. You get this equation 1, that was the x component. Equation 2, it is y component. Equation 3 stands for direction, and equation 4 stands for magnitude of vector in terms of its components. That's it.